Okay, well, thank you everyone for coming tonight. It's been a few months, so we're happy that y'all are here. Um, just by way of announcements, we changed the schedule a little bit for In the Company of Stewards this year. So instead of doing it every month, we will doing it every other month. So February, here's our first one. So we'll do February, April, June, August, and so on. And we are alternating months with the book club. And Peter is here and he runs our book club. So if you want to join, you can talk to Peter. I have a link to sign up for the book club newsletter too that I'll put in the chat in just a second if you would like to participate on the other months, so January, March, etc. And the book club meets the first Wednesday of every month. Also, if anyone's on TikTok, we now have a TikTok. So I'm trying to spread the word there. I'll put the link for that in the chat too. Tonight, we are excited to hear from the BYU Wind Energy Club. So as their name would suggest, they do research in wind energy and wind turbines and sustainability. We have a couple presenters, so we have four. You can see Hannah on the screen here. She's also got Dylan, Ian, and Kyle with her. The BYU Wind Energy Club, they'll introduce themselves in a minute. The BYU Wind Energy Club, they compete. And they may tell you a little bit more about that, I don't know, but they compete in a national college competition that's run by the Department of Energy. And I believe they, a couple years ago, got a pretty big grant from the Department of Energy to do research that I read. I don't know. I don't know how old the article was, but maybe not. But they do cool stuff, cool research about wind energy. And a while ago, we sent out a survey, and there was a lot of interest from our audience in renewable energy. And so a couple months ago, we talked about solar energy with Mike Maxwell, who may be joining us tonight. So tonight we get to learn about wind. So I will stop talking and I'll stop sharing my screen and I will turn it over to Hannah and the rest of you if you want to briefly introduce yourselves and then we can get going.
Thank you so much, Chloe. That we will do. Okay, I'll have us introduce ourselves first, and then I'll start sharing my screen so that you can see our faces first. But my name is Hannah, and I am a senior in mechanical engineering here at BYU. I am interested in energy systems and have been interested in energy systems since I took my first thermodynamics class, which kind of introduces the topic. I am currently planning on getting a master's degree at Texas A&M starting next fall. And that's a little bit about me. I'm from Sandy, Utah. And then I'll pass it over to the other people here, or you guys can come on in. So.
Hi, my name is Dylan Jensen. I am one of the few electrical engineers on the club and in the capstone team. I am from Provo. Wait, let me stop sharing my screen over here. I don't want to see two of me. That's kind of disconcerting. There we go. Okay. I'm from Provo, so it's awesome to go to school here, but I'm getting ready to go into a PhD program at Stanford, where I'm going to be working on electrical energy systems and sustainability. And that's a little bit about me. There you go. I guess on the team, I guess I've been in charge of designing a power regulation system. So that's more my area of specialty and left the mechanical stuff up to everyone else. So anyway, take it away.
For sure.
On the opposite side of the spectrum, I am a mechanical engineer and I also have very little experience. I'm a sophomore here at BYU. I'm from Salem, Oregon, and I just have a huge passion for the earth and for making big changes. I really think that we have a huge responsibility to contribute to making some really big changes in this world as we move forward. So that's a little bit about me.
And I'm Kyle Havey. I am a junior in mechanical engineering. I'm from Chandler, Arizona. And I also really like energy, any type of energy engineering. I plan on getting a master's in nuclear engineering after I leave BYU. I still don't know where yet, like these two, because I still have a year left.
So So if you have any questions for us individually, feel free to keep those in mind and we can answer them at the end in our Q&A session. So I'm going to share my screen really quick and then we'll get going into the presentation part of our presentation. Here we are. Okay. So we are super excited to be here tonight with you guys and super excited to be talking about one of our favorite topics and the topics that a lot of us are planning on doing our capstone project on, like our full year senior year project, or are already doing so. Tonight we want to talk a little bit about our team. We'll talk about what we do. We'll talk about not just wind energy, but kind of the basic engineering behind wind energy and how it works, and define a few terms. Then we'll talk about the pros, cons, and general misconceptions that people have when it comes to wind energy. The biggest development obstacles that we face when it comes to bringing more wind energy into our society. And then we'll tie it all up with our thoughts on sustainability and earth stewardship and how wind energy falls into that category. So I'm going to start us off. We are a mix of a club and a capstone team that works on the collegiate wind competition, which has 4 parts. There's a part where we build and test a mini wind turbine, and we throw it in a wind tunnel, and we try to compete with other colleges and see which turbine scores the best in certain categories. We have a part of the competition that is focused on creating a business plan for a theoretical wind farm. So this year, I mentioned a little earlier before we started that we are asked to design a wind farm that would go in the Great Lakes. So that involves all the project planning, all of the different aspects of putting together a wind project. And we do a write-up for that. And then we also do community outreach. So we've gone to some schools, we are coming to, and we get to present with you guys. We do different business interactions and things like that. So we are all united by our interest in energy systems and renewable energy and sustainability. So we're excited to be here with you guys. So that went through that slide pretty fast. First thing we're going to talk about a little bit is how energy works. And we were thinking that just because we've all been studying this for a while, so we have kind of a more in-depth picture of how you get from wind into electricity, but we figured that not everybody would likely have the same kind of in-depth understanding. So we're going to talk a little bit about that. And basically what you need for a power system to work are magnets, wire coils, a source of energy, and a way to store and distribute the energy. So in order to kind of demonstrate that a little bit, we have some demonstrations, and Dylan is going to take over the camera for me so that we can stand up and come up.
Got a couple thumbs up. Looks like we're good.
Okay, cool. So basically we're going to start with the first demonstration. And what I have in my hand here is a normal bar magnet, North Pole, South Pole, typical magnet. And what I have here on the board is a coil of copper wire. And it's covered in electrical tape and connected to a set of LED lights. So the basic physics principles behind creating energy is that magnetic fields and electrical fields interact with each other. So when I move my magnet inside of my coil, you should be able to see a flash. I don't know how well it's going to show up on the video, but you should be able to see that that LED is flashing. People seeing that? Okay, good. Now, obviously, this only provides a short burst of energy, and it's not very efficient to be sitting here, you know, having a whole bunch of people go like this in order to turn on the lights in the building, right? So engineers have started coming up with a generator. The basic idea behind a generator is that you have a coil of wire or multiple coils of wire and magnets hooked to each other. And when you rotate them, then it has the same effect of putting the bar magnet in and out of that coil of wire, but it's much easier to rotate it and much faster to generate the energy instead of going in and out. So, however, this does take a significant amount of force. And Ian is going to help demonstrate that significant amount of force. So right here, this is a hand drill, and we're going to use the hand drill. If you turn the hand drill, it basically works as a generator like this. This is what's going on inside of a drill. Normally you put electricity in and it spins it, but if you spin it, you'll get electricity out. So he's going to be doing this and it's going to get loud. So as he is doing this, I'm going to be turning on lights. And I want you guys to watch his face and kind of see how he is doing as I add more of a load to his system. So. You're good.
Good job.
Applause for Ian. He's getting his nightly workout in for us.
Okay.
We won't ask how he hurt his arm.
He was generating a lot of power.
A lot of power, for sure. Let me pull this back up. Okay, and maybe is my video
It's still back. Sorry.
I'm back. Okay. So, hopefully, as you can see, it does take a significant amount of force to generate even a small amount of electricity, which is why we have power systems like big generators, power plants, and especially our favorite, wind turbines. So this is the inside of a wind turbine, and for scale, if you see there's two people that are easily seen in this picture, and then there's one little shadow man who's standing underneath the little hood back in the back. These things are massive. So they have a lot of torque or rotational force that we're able to use to turn our wires and magnets. So if you look at that big blue thing, that's basically a gearbox that takes that massive amount of force and turns it into speed. And then the silver thing that you see on the front right is where the magnets and coils are stored. So for this energy system specifically, the energy that we use is the wind. In a lot of other power plants, power sources, it's going to be hot steam that's heated by something, whether it's nuclear heat source or burning coal or gas or something like that. And the hot steam will turn basically turbine blades, but on a much smaller scale than a wind turbine. So before I pass the time over to the others and they start talking more about specifically wind energy, I wanted to talk about a couple of terms just so that we are all on the same page when we're talking about it versus however you guys define it, just so that you know when we say these words, this is what we mean. First is renewable energy, which is what we all love. It comes from a source that is naturally replenished and infinite in supply. So this is wind, solar, geothermal, maybe tidal, if we can fit that in later. But and then the trickier term to define is sustainable energy. And sustainability often is interchanged with renewable energy. But it really depends on the needs of the society. If a renewable energy source is unable to meet the long or short-term needs of a society, it's not necessarily considered sustainable. And if it is, then it is also considered sustainable. So they're not necessarily the two terms. And you guys probably already know that. But when we say it, we just want to make sure that you guys know that's what we mean. So with that, I'm going to turn the time over to Dylan, and he's going to give us a little bit more about pros, cons, and misconceptions.
Thanks, Hannah. She's awesome. Well, we're preparing for this presentation. Chloe asked us to talk about the pros, cons, and misconceptions of wind energy, maybe cover some things that are commonly misunderstood. And I also, as I was trying to decide on the things specifically to hit on, I was more impressed. Like, I just feel like wind energy is so simple and it's so beautiful, but it's also so cool at the same time. So like, it definitely has pros and cons, but they balance each other in such like intricate and beautiful ways. So I'm going to start off with maybe one of the less glamorous ones, but one of the big reasons I feel like wind energy is appealing, which is just the raw cost of producing energy. This was a recent study that was collected in April 2023. They broke down basically every common source of energy production that we have, and then they ranked them according to how much it costs to produce like a set amount of energy in megawatt hours. As you can see on this ranking, all these dark blue lines are like just the cost that it takes to construct and maintain a power plant of a given energy source. And you can see down here, wind energy, onshore wind energy is so accessible and so like such an easy energy source that it's actually ranked on the cheapest end of all energy sources here. It's like on the low end, it's tied with solar power. And then you even see these faded lines like this like darker or this lighter gray one. This is with US subsidies. So this study only took into account the cost to literally build and maintain the power plant. But then when you take into account the environmental impact that a certain power source has, you'll notice very quickly the United States government will subsidize wind and solar power to the point that it can essentially be free to produce power in terms of the power company, because it's so worth it for the environmental impact that like the government will pay you to build renewable energy manufacture or energy capture plants. I just think that's really telling in and of itself, just that you can like already, even without the subsidy, wind power is so cheap. Then I guess you raise the question, if it's so cheap and so accessible, then like what's the holdup? You know, I think maybe this is one of the misconceptions. When I first started learning about wind energy, I got so excited thinking like, this is awesome. We should just build power plants all over the place. And I do think that we have a lot of room to expand, but I also think it's important to be careful and say this can't be our only power source. It can be a major power source, but one of the issues that we run into is that wind energy is an intermittent source. That's going to probably feel pretty intuitive to you because you think, you know, like I go outside and it's windy, but it's not constantly the same like amount of wind. So over time that will ebb and flow. It will be sporadic even when it's a windy day. Daytime tends to be less windy than nighttime. So what we come down to is that we need to be able to integrate wind energy with other types of energy production in order to really get that sort of level, like meet more constant power demands. I guess one of the open fields in research that is helpful to wind energy and sustainable energy in general is what's called energy storage. If you have a wind plant that's putting out way more power than you actually need at a given point in time, then there's a lot of research into using that excess energy in ways that you can store it, whether that's charging gigantic banks of batteries or getting something spinning really fast that you can later use to take that energy back, or lifting something heavy up to a high height, and then you can use gravity to turn that potential energy into electricity again. Like it's an issue that needs to be addressed. That one of the things that makes wind energy maybe a con of wind energy is that it's not so easy to integrate with a traditional grid. You know, whereas a coal power plant, you can just turn the dial, so to speak, and it will put out more power as you need. Wind energy, you need to take into account the more sophisticated system of how to store the energy and how to make it work with other sources so that you can really meet grid level demands. I guess another thing I find very interesting is this blue line right here it traces out the path of where we get most of our energy in wind turbines, where the wind speed is increasing here on the x-axis. And then the reason that this this curve increases as the wind speed goes up, but then it comes back down, and that's because we just don't have these high wind speeds very often. This is especially over land. So this was a survey taken in Colorado over a couple of years, and they said they do get most of their power over these high wind speeds, even though they're not very common. So what this leads us to end up doing is we're trying to build a lot more wind farms over the ocean. That has the advantage of over the ocean, they have much higher, consistent, sustained high-speed winds, which like exponentially, actually more than exponentially increases the amount of power you can get out of the wind, which is awesome. Like that's great that you can operate just one turbine and get 10 to 15 times more power out of it. This is really wonderful. It's also significant that it doesn't have as much of an impact on the landscape. Like it's less environmentally impactful to have a floating wind turbine just out in the ocean where you're not, getting in the way of forest or other more complicated habitats. And you also don't have to see them. I feel like a lot of people are opposed to wind turbines because, I think they're beautiful, but I don't know if that's a common opinion. It is a little bit weird to have some janky fan just like blowing out there all day. Maybe it looks scary. I don't know. But if it's out in the ocean, you can't even see it, right? This does come with the cost of it. It is trickier to build a wind farm in the ocean. Like you can't just drive a truck out to it. You have to get a gigantic boat and somehow like anchor it while you're building it before it can take its own weight. And then it's also important to remember that I wouldn't say that this is necessarily a huge concern. The research doesn't make it sound like wind turbines are destroying birds, but it is important to remember birds have their set migration patterns, and you have to take that into account when you're selecting a site for where to put your wind farm. I don't know. I guess maybe that's something that people will see in a very public eye, because if a turbine hits a bird, it will kill it and you can see that. But it's a lot harder to observe that with other forms of energy. Like a coal power plant is not directly sucking in birds, but the environmental impact that the greenhouse gases have, and just the cost of mining and consuming coal and other fossil fuels has a much less visible, direct, but much greater impact on the environment. So I don't know. That's what I would say. I would say it's definitely a pro that they're much greener than other forms of energy, but you also have to take into account the impact that it will have just to build a structure somewhere in an active habitat. So I believe that's the end of what I had to say. I'm going to give this over to Kyle. He's going to tell you a little bit about how to develop a wind farm and what makes it so tricky to get it running. There you go.
Okay, so I'm going to go over a couple of things of how you get a wind farm like up and running and what it requires to go through that whole process. So I thought I'd start out with a timeline of like what has to happen in order to build a wind farm. So one of the first things you have to do is project planning. You have to get a project idea. You have to choose a plot of land that you're going to use to build this wind farm on. You have to consider everything that'll affect, like who's going to get this power, what's in the area that we're going to affect. And you have to put together this whole proposal that requires a lot of research. After that, you make the proposal and you include how much is the entire, wind farm going to cost and how much money is it going to make by selling energy. That's usually a big, long financial proposal. You have to get a lot of financial expert work on that. The next step is who's going to pay for it. A large wind farm project can cost over $1 billion. And most companies that are building these wind farms don't have that kind of money to spend. So they have to get help from private companies. Big private companies can buy and help pay for a wind farm because it helps them with their taxes. They get tax money back for it for helping a clean energy project. And then after all of that, it still has to get built, which means you have to go through the whole process of planning the construction and actually building the project. So one of the big problems is supply chain problems. Over here on the picture on the right is a wind turbine installation vessel. It is a huge boat. That's like a really, really big boat. And it is the only thing that can be used to build offshore wind turbines. There's lots of demand for the boat because there's only a handful of these boats in the world. One example of a project gone wrong because of this is the Ocean Wind 1 and Ocean Wind 2 projects in New Jersey. Currently in the United States, I think we have a total of like 5 or 6 wind turbines that are offshore, like 6 turbines in total. It's not a lot. Off the shore of New Jersey, they were going to build hundreds of turbines. It was going to be a massive project. It was going to power a big chunk of New Jersey. When they got the whole project figured out, they had funding in place, everything lined up, and they were planning on getting this wind turbine installation vessel to build the project. But when they tried to reserve the boat, they found that it couldn't be reserved for several years, like 5 or 6 years out. And since they'd already started everything else on the project, it pushed the project back by almost, half a decade. And it made it to where they were too far in that they were not going to make any money off of this. So they canceled the entire multi-billion-dollar project. And it was just because they couldn't get the boat. That was the only reason the project didn't get built. It was just too costly for them. That's more of an offshore problem than an onshore problem. We have the onshore supply chain figured out pretty well to the point that there's not major problems like that. But there are other problems that I'll talk about. Another one is public perception. So one of my favorite acronyms is NIMBY, which stands for Not in My Backyard. It's, you have a large group of people that are pro wind energy, but they don't want it to be built near them. They'd rather it be built by someone else, and that someone else would rather it be built by someone else. And so a lot of groups or a lot of areas don't want wind farms built near them, but they still want the wind energy. It's kind of a weird problem, but it is a problem. If people don't want it built near them, that'll be resistance to projects trying to be built. And that makes it harder, it makes it more expensive. Another problem with public perception is things like noise. That has to do with the not in my backyard. A lot of people will say that wind turbines are very noisy, and that's the reason that they don't want it near them. I've seen that one around a lot. A lot of people talk about the noise. I don't fully understand it. I've been I've stood at the base of wind turbines before, and they make a little bit of noise, but it's not like a crazy amount. Like you get a mile away and you can hardly hear it at all. But that's just my personal opinion. I don't know how. I think other people might see that as a bigger problem than I do because I'm a big fan of wind turbines. Another big problem with building these wind farms is connecting to the grid. So every wind farm has to connect to the grid in the US to be able to power anything. If you just build a wind turbine, you don't connect it to anything, it'll just spin and not do anything. So I included a map of the United States grid. It's split into the 3 sections of East Coast, West Coast, and then Texas, along with the different power lines that go around. So one of the problems that I've put on here is the interconnection queue. What that means is when you build a project or plan to build a project, you have to get in line to connect to the grid. Because if everybody connects to the grid at once, you can burn out the grid, which makes everyone have blackouts, and you lose a lot of money, lose a lot of energy. And so there's a line you have to get in order to connect your project to the grid. Currently, there are thousands of projects waiting to be approved to connect to the US grid. A fun fact is that the projects that are in line to connect to the grid make up more power capacity than all the power plants in the United States. That's kind of a crazy number to think about. These are projects that are just waiting to be built and they have to be approved. And then once they're approved, then they have to get all their funding together to connect to the grid. But there's enough people that want to build wind power that we could, replace all power in the US with wind. There are some problems with this. I'll go on to the next slide is power lines. So I showed the map of all the power lines previously, and the grid in the United States was built for coal and for gas. And that's because we're using the same grid we've been using for the past, 100 or so years. Back when the grid was built, there weren't massive wind turbines. And so one of the problems is that you need to connect these wind turbines and wind farms to high voltage power lines. Wind farms are typically far from cities, far from urban areas. And in order to get the power to them, you need high voltage power lines. The problem is that high voltage power lines can be expensive, and the cost of these power lines is put on the people building the wind farms. So these costs could add up to like $250 million or more just to get the connection to the grid. And a project is already pretty expensive as is, some projects being around $1 billion. So to add another $250 million on top of that could be the difference between it being too expensive to build and just barely being able to be built. So a lot of projects get cut because they can't afford this connection to the grid. So this will lead into, we're going to lead into next is how this relates to us as Earth stewards.
Okay, hi, I get to go now. So as we can see, we have a lot of really cool opportunities and challenges with wind energy. It's a renewable source, has so much potential in helping us do so many things with that energy. But we do have some really big challenges to overcome going forward. I want to emphasize first off, I love the earth. I love the earth so much. Like really, I really love the earth. And I love this quote from Bishop Budge because it kind of synthesizes some views that are difficult to bring together sometimes. So he says that the earth is full and there is enough and to spare. If we act as good stewards, there are plenty of resources for the needs of our brothers and sisters around the globe. And I think that is such an important thing. And I love that you are all here with that mindset. We have so many things that we need to work on and to grow. And I think it's so important to keep those perspectives in mind. We learn from the Book of Mormon that the reason that we have this earth is that it's supposed to be inhabited, that God has given us this earth, that we can possess it, that we can learn and grow. And I personally think that one of the best mindsets to keep is what the Savior taught in Matthew 25 in the parable of the talents, that thou hast been faithful over a few things, I will make thee ruler over many things. So to me, that speaks volumes to stewardship. To me, that's the Lord of the universe, the creator of everything, saying, I've given you this earth. Let's see what you do with it. And President Nelson reminds us as well that this earth is a means to an end. One of those ends that connects to energy is the sealing of families. And I just want to demonstrate because this is one of my favorite examples. I'm a really big family history buff. And so when we talk about energy, and maybe we can start to see some of these connections to wind's energy, is the work of salvation is really pretty directly connected with energy and the energy grid and supplying all this technology. We have things like Family Search, which I'm fortunate enough to where I think my experience with genealogy and family history has been a lot more simple than what most of you probably grew up with. You know, I've never had to dig through volumes or go to libraries. It's all right there in front of me. Even now, this is a really cool thing. We have AI that's even replacing indexing, which was like, wow, we have indexing and we can access all these records. Now we don't even have to be the ones to look through and decipher all these cursive handwriting. The computer does it for us. So many wonderful advancements that are directly connected to our energy system and these technological advancements. We can see that on a global scale. You know, I've been able to help people in Africa with their family history. And so with all of this that we've discussed, with all of these challenges relating to these projects, and yet this stewardship that we feel, I want to pose the question to you, and we can reflect on that for a couple of minutes. How can wind energy, how can this sustainable and renewable, depending on, you know, what our demands are, form of energy help us to be better stewards of the earth? And maybe what can we do to use wind energy to be better stewards. So I encourage you to just maybe take a minute, think about that, and put your ideas in the chat. We'll read them off.
Thank you so much, Wind Energy Team. Hannah, Dylan, Ian, Kyle. Thank you.